Thank you for your patience. We will not now start the webinar. My name is Hanani Moreno Nieves. I am the head of digital services and marketing at Actility, and I will be the moderator today. Welcome to today's webinar, Mitigating Risk in Precision Hazardous Zones, Real-Time Tracking for Enhanced Worker Safety in Oil and Gas. Today, we are joined by a fantastic panel of experts, Nasri Nasreddin, Vice President, Middle East, Turkey, and Africa at Cumulocity, Wael Al-Kadamani, Country Director at Cumulocity, Hussein Al-Rashid, Digital Transformation Specialist at Saudi Aramco, and Nicola Jordan, COO of Actility. So here is what we have planned. We will begin with an introduction panel about the importance of IoT in oil and gas from Nasri Nasreddin. Following Nicola will walk us through Abiway trackers and LoRaWAN technology, while Al-Kadamani will discuss the role of IoT in oil and gas safety, including a live demonstration with real-world use cases. Hussein Al-Rashid will share the customer feedback and provide insights into the seamless integration between Actility platform, Abiway trackers, and Cumulocity IoT platform. Finally, we will wrap up with a live Q&A session of 20 minutes, where you can ask all your questions to the experts. But please feel free to add your questions in the chat at any time, and we will answer at the end of the webinar. So further ado, let's get started. Now I hand over to our first speaker, Nasri Nasreddin.
Thank you, everyone. I'm just going to give like a quick briefing around the challenges that we are facing in oil and gas and what the potential that we have it. But before that, it would be good to tell you and share with you about Cumulocity. Cumulocity is a world-leading IoT platform, started since almost 10 years. And we are actually very much specialized on how to liberate data from unusual sources, which is devices, sensors, assets, and so on, and make it available for users and utilizing by all users. We spread in many countries in the world. We have thousands plus customers, and today we're going to focus on the role of IoT in this domain that we are talking about it today. Before just we give the team to start explaining a little bit about the contents, I would like just to share with you some of the key challenges we are facing in the most advanced sectors, which is the oil and gas and the energy sectors. We have come up with 4 key challenges. The first one is of course, as you know, and especially in our region, in Saudi, in UAE, and in these countries where the geographic become really of a great challenge. You know, many times we hear about these areas where there's no proper connectivity, where we are talking about these distributed assets that it's hard to reach and hard to navigate across, about some blind spots and so on. So, you know, this sometimes introduced safety and management challenges. Second, and it's quite common, when we hear about like gas leakage, we are talking about pressures bursts here and there. All of these things are actually creating, sometimes because of the temperature, sometimes because of the operation, sometimes because of labors, that counter so many challenges on the distributed assets across. So higher risks, the more assets you have, the less connectivity you have, the higher risks you have. Third is also another critical when it comes about how we are able actually to have enough access and flexibility from tracking to these assets and devices. How we can make sure that this goes side by side with the safety regulations and make sure that the operation is more efficient. When you don't have this ability to track, or when you are not able to manage the efficiency across, then become really of some of the classic efficiency issues. The essence of real time, and especially recently, become of high demand. The latency, the concept of latency, it's actually create another dimension of issues. So we need to be on spot. We need to take a serious and immediate actions, and therefore the real time essence is an important. Now, these 4 challenges, although they have been there from long time, but the criticality or the level of criticality, it's increasing as we move on. And the more trends we are facing, the more challenging we are going through. So why IoT matters for these sectors, and why it's important to consider from monitoring and controlling using the Internet of Things as technology. First of all, it gives you an instant visibility. You know, if the power of visibility of the data across help you to take the right decisions, give you a sense of the behavioral analysis of your assets. How is it behaving? What are the potential challenges? If there is an immediate issues, who's actually adhering to the regulations and so on. So the power of visibility help you to take an immediate actions to avoid or to have a better control on these risks. Second part, which is how to be proactive rather than being reactive. How I can have this way of aggregating between historian data and real-time operational data. So I can predict if this is going to be a failure and what actions and precautions I need to do. How I can actually make sure that a potential downtime can be avoided rather than waiting till the issue is happening and so on. Geofencing, we talked about it, and we talked about the power of connectivity and how we make sure that we have a clear coverage across. We don't want to have an areas that is not controlled or not monitored, or there is a lot of potential unauthorized activities that can happen in these things, whether it's an asset or whether it's an employee across. So this works side by side with the safety, as we said. Digital twin, it's not something new. It's been there from a long time, but its criticality become higher and higher. How can you have a digital replica of your operation from the physical assets, but you have actually the digital representative of these assets? Whether it is a spinning motor, whether it's a fan, whether it's a cooler, whether it's a pipe, I need to have the actual graphical representations of these assets. And this is part of the empowerment of visibility. And it helps you how to look at it from productivity as well as from operational efficiency perspectives. So what are the common applications that could be productized or could be actually used or utilized across? So first one is about the worker safety. Everybody knows, and especially this sector, count a lot on laborers, count a lot on on-field employees, workers, and it's very important. We have these types of mechanism or algorithms or these types of equations that connect assets with alarms, with incidents, in order to make sure that we maintain a higher worker safety. I mean, the last thing is we expose people to risks, and this is what we need to avoid. Same as people, we have also the assets. Assets tracking could be in many levels, in many dimensions, in many departments. Could be a truck, could be a fleet, could be a car, could be any type of trackings that I would like to do it. Inside, indoor, outdoor. It could be, for example, in a short range and higher range. But the logistics by itself, it's a key component for the oil and gas. And therefore, the efficient logistics I have, the efficient tracking or monitoring perspectives and real-time aspects, the more efficiency I introduce to my operations. Predictive maintenance, and now these days, especially with the explosion of AI, that can avoid the potential failures, and by predicting things and by being proactive rather than reactive, how I can make sure that I can take the necessary actions before things happen. So predictive maintenance across everything could be any type of assets, could be an integrated assets, could be mobile devices. All of these things are important to look into the healthiness of these assets and the operation, how can be optimized. Last but not least, beside IoT, besides sensors and devices, we cannot and we should not avoid the connectivity. Connectivity is very important. If there is no connection, there is no reading. And if there is no reading, there is no action, reactions, and everything. And this is where, for example, LoRa play an integral part. Although there is so many aspects of connections, there is a satellite, there is GSM, there is Wi-Fi, there is many things. But LoRa proven to be very much effective especially in certain jurisdictions that it need to be monitored and controlled and so on. So it's important to know what are the recent challenges, solutions, and applications associated across. But during this session today, I think we will highlight more about some of the content across, and glad to take your questions, if any.
Thank you, Nasri. Let's now welcome Nicola Jordan from Activity.
Thank you, Nasri. Thank you, Janany. So, of course, yes, thank you for these transitions as we just discussed about the need, the use case. Let's move now to the slide deck related to the important enabler that you will need to be able to deploy this type of use case that has been mentioned. So in this slide, and I won't go into the details, this is not the idea, just to let you know that there is a very large number of technology to be able to do Internet of Things, legacy technology, and but what is important is that to be able to serve all this use case, you need to get the proper connectivity, as is just said by Nasri. I'm used to say, like, I don't know if you remember, but the first iPhone didn't work. The second iPhone worked because it was 3G compatible. And without the 3G and the high bandwidth capability, all the business of smartphone couldn't work. So it's the same for IoT, it's the same for the use case that we are talking today, mostly, of course, worker safety. You need to get the proper connectivity. And regarding all this landscape, the dominant now technology, and we show some figures later on, is LoRaWAN. So this is and in this slide, you have two dimensions. The one is the range. You need to get the capability to interconnect in radio, very large plants, very large refineries with all metal constraints, in terms of radio performance. You need to reach maybe a complete oil and gas, very wide sites, offshore rigs, and these kind of things. And the legacy radio technology that we, like Zigbee and others, cannot reach this performance to be able to easily and with a reasonable TCO address the range in terms of span and size to be able to cover the area regarding where the use case of potential thousands of workers must be monitored. The second dimension is the battery lifetime. Bon, I mentioned cellular, but we are recharging regularly our cell phones. But of course, in IoT is different. Most of the use case, including the worker safety, are based in the fact that the sensors is battery-based and must really have long time life capability. Couple of months, even couple of years, on the example predictive maintenance or submetering of meters. We are even talking about 10 years and even more. So, and the best technology to be able to reach the size, the range, very long range capability of multiple kilometers. By the way, this technology works even also with satellites, so that show you, of course, how the range and how efficient it is, and the capability to really drain as less energy as possible is LoRaWAN. And this is the reason why most of the use case and solutions that you can see use this technology. Of course, you probably heard that cellular technology also have now embraced IoT, like NB-IoT, LTE-M. You still need some for use case this technology, but most of the sites, mining or oil and gas sites, the cellular coverage is not there. Sometimes you may have private, even cellular, Tetra technology or private 4G, 5G, but what you really need to have something extremely convenient to be set and I'm used to say that LoRa is the, let's say, Wi-Fi for IoT. We are used to plug our Wi-Fi routers at home and then having our Wi-Fi bubble around. But now we can have this equivalence by plugging a box and then having called a gateway and having a multiple kilometers range capability to interconnect all the assets in the area. As simple than that. This is why really LoRaWAN is really completely suitable for most of the IoT use case today, and it's really becoming a dominant technology. And this is the figure that because we are a member of the LoRa Alliance, we get on a yearly basis from the VDC group. in this graph, I underline that China has been excluded because it's true that in cellular technology, China is very dominant. But if you remove China, you can see at the bottom of each graph now how LoRa is becoming really dominating technology for private network. Of course, cellular is NB-IoT and LTE-M of course are dominant, but you can see if you remove out China, they are quite equivalent. And so having the capability to get the proper technology at the proper place privately with a TCO cost, very low price for very low TCO capability, LoRa is again the best technology. And now he has been adopted by most of the industrial vendors. We are working with, of course, by Aramco, this is the subject of today, but also with ADNOC, also with TotalEnergies, with ExxonMobil, with ConocoPhillips, not mentioning. This is why this technology has been adopted. For those who are not fully familiar, this technology is now it's an industrial standard that has been managed by the LoRa Alliance. And just to show you the commitment of Actility and our, let's say, experience and knowledge about this technology, and the reason why we are one of the market leaders is the fact that we are the pre-founder of the LoRa Alliance. Actility, in fact, bring as an open source the MAC layer, what we call LoRaWAN. We wrote the first specification that has been provided as an open source to the LoRa Alliance, and we are still leading most of the innovations within the LoRa Alliance. IBM at the time was bringing all the security aspect. Security is key, even more in your business, and things has been managed extremely seriously. And for those who doesn't have the expertise, we can, of course, offline during meetings, get into the deep details of how the security is managed over the LoRaWAN technology. And Semtech owns the patents regarding the radio modulations. So the three companies have created the LoRa Alliance that have more than 800 companies right now, startup, telecom players, established company, very wide industrial companies, very small one, and it's the growth of this alliance it's huge, and it has been able to create a very wide and large ecosystems of sensors. You have sensors available from all around the world, cover many use cases. We have a marketplace, by the way. We can later on share the link. And over this marketplace, you can find hundreds of sensors that solve most of the use cases that you may need. And the reason why this ecosystem is so huge is because there is an alliance that is really certified the interoperability of all the vendors within this ecosystem. Then the connectivity is the first enabler. The second one is, when we get back more closer to the worker safety, is the fact that among these players, Actility has acquired a couple of years ago a company called Abiway, and we have been specialized in tracking of assets with more, let's say, let's have one here, more, let's say, this black device that you, of course, can put into any type of asset that you would like to track. And also, additional to that, a smart badge. And when we are mentioning about worker safety, we are mostly referring to that device that can be handled under the neck or somewhere, or also sometimes on the helmet. And this worker safety smart badge is one of the, of course, key elements of the use case right now, because you can, of course, having the button send an alarm to warn where you are and be automatically geolocalized. You can be rescued as quick as possible. Additional to this, the usage of this smart badge, it's also a good way for oil and gas players to also monitor the resources with more efficiency and the productivity by knowing where are the staff, knowing who is working where, and also that's a good productivity tools, additional to the fact that you're increasing the security. To be able to work on these oil and gas environments, you need to get specific certifications, and Abiway has worked a couple of years to be able to provide the first, most famous one called ATEX certified technology. But there are, of course, other more international flavor like IECX. And recently, the compact tracker devices has been also certified for the US market C1D1. So if you get back more general, for the Middle East, ATEX is most of the time fine. We have ATEX 0 or ATEX2 for this compact tracker to monitor the asset, and ATEX1 or 2 for the smart badge. For those who are not so familiar, it's the level of the fact that being 0E2 allowed you to be more in, let's say, explosive environment. Having B ATEX 0 allowed you to really having this asset and guarantee that there is no sparkling and any risk, of course, of explosions by not generating its sparkling on this specific area. But I guess all of you are already very familiar with this. The third component in that slide, the casing look like the same, but it's very important. When you are missioning tracking, we are talking about tracking outdoor and by using satellite. I'll get back to that next slide, but also indoor. And for this, you will need also technology to be able to triangulate the positioning of people within buildings. When you have, of course, not access to the sky, the GPS won't work. And for this, most of the time we use beaconing, Bluetooth beaconing technology, and we have, of course, based on the same casing, the capability to provide managed ATEX beacon that and with IP68, so very completely designed for very rough environment that can be, of course, oil and gas rig. So tracking asset, tracking people, ATEX and other technology certified. Rough casing, that's the perfect, of course, combo to be able to serve the use case that we are discussing right now. That when we get, of course, more in the details. The overall architecture, Hussein will get back to that more in live, but we have the devices here. We mentioned this famous, let's say, gateway box that to create the LoRa bubble that you install. It can be there are outdoor gateways, indoor gateways. Everything is connected to a concentrator that's coordinating the messages and the quality of service of the network. It's called a LNS, LoRaWAN Network Server, and Actility is providing one of the most advanced LNS over the marketplace. This is also is connected with when you are, because in that case we are talking about tracking assets, so you need a solving technology because tracking asset or human can use GPS and triangulations of BLE or even Wi-Fi, and you need for that a specific applications to triangulate and compute the positioning within the buildings. And everything is connected to the application where you will see the graph, see the positioning, set the alarms, and everything that is provided by Cumulocity. So you have Abiway here for the device, Actility in the middle for the LNS part. Actility or potentially also Cumulocity are sharing also the solving technology, and all the display and the application and related to the detailed use case is provided by Cumulocity. So how it works? So for outdoor, as I said, when you are outside the buildings, I guess you see my. I don't know if you let me change the arrow. I think now you should see my mouse moving. I hope. So here you get satellites when you are outside, of course, the buildings to get the positioning. We also do Wi-Fi sniffing. So if you are in the city environment or there is a lot of Wi-Fi pre-registered, like a cell phone does, you can also triangulate the public Wi-Fi by using a database provided by company like Ear or Google. But when you move inside the building, then of course you cannot work anymore with the satellite. You need to triangulate other technology. That's why this is where you put this famous beaconing, BLE most of the time. More you have BLE beacons, more accurate you can. So it's depending on the use case. Do you want to know if the guy is precisely here, or just you want to know if it's in this room, its floor, or an average area? And to the accuracy is depending on the number of beacon, and you will adapt the number of beacon regarding the use case and how precise you want to know where is the worker of the asset. This device managing its positioning with the satellite and the BLE and resend all these messages through the LNS that it's sending to the solver, and then put it back to the Cumulocity for the application and display side. That's the way it works on the positioning side. But of course, you have additional features and included inside the tracker themselves by detecting this, because it's a very common use case that we have with companies like Tata Steel and others. It's detecting the safe zone and the hazardous zone. And even if you may lose some connectivity for any good or bad reasons, you need to get the sensors, the tracker, be able to warn you if you are in a hazardous zone. And inside, you have a very advanced firmware that allows you to detect regarding the BLE address if you are allowed, or if you need to get an alarm because you need a specific equipment, or because you are not allowed to be under that zone. All these are proven, let's say, advanced features embedded directly into the tracker reinforce the security aspect. And of course, but most of the time, because we design correctly our network and related to the great performance of the LoRa technology, you'll be connected directly to maybe mobile applications or whatever third-party applications that Cumulocity will complete the local messages of the sensors by additional messages coming from the Cumulocity applications in live. Asset can be monitored. There are also use case, not only the positioning, but if, again, for productivity, you want to do predictive maintenance, as has been mentioned by Nasri. So there is an accelerometer, and we can detect the vibrations pattern. And if the pattern goes wrong, then you can, let's say, anticipate, get into the systems to repair it before it falls down and avoid any outage. But also, if you want to monitor that effectively, the workers are effectively using the machine. Are they really they're supposed to do? It works also for inventory needs. Most of the case, you rent very expensive tools, machines, and then, but because you don't monitor correctly your asset, you don't know that there is one a few kilometers next to you and they can be reused. And of course, having a tracker and knowing if it's used or not by detecting the vibrations of the systems can also help you to reduce costs by managing more cleverly the number of your asset. Yeah. Okay, so we get back more in details regarding what we do with Aramco, but we are really developing this for a lot of worker safety. This is example that we do with Petrofac. Well, the same use case, so I won't get in more details. I think you get it. You get the point. In Oman, Tata Steel, I mentioned, it's very huge deployment for us. We are really talking about 200,000 trackers to monitor the security of the workers. This was a previous casing you have on screen, or previous generation. And just to show you how it works very nice indoor. For the Olympics in Paris, the subway has been extended and the workers have been monitored in case of accidents within the tunnel. So that's another cool example. You don't need ATEX for this, but just show that the fact that it's also work as well outdoor and indoor.
Thank you, Nicolas. So now let's hand it over Wael Al-Kadamani, Country Director at Cumulocity.
Everyone joining the webinar. So in my slides, I will take you through some of the use cases that we have developed using Actility and their devices, all developed in Cumulocity platform using LoRa network in oil and gas sectors. Before we start with the use cases that we have done, I just want to quickly go through why Cumulocity is good in oil and gas. So we have many reasons, to be honest, which most of them has been explained earlier with my colleagues, but we have some great integration part for the devices with Cumulocity, specifically Actility devices, which is the gateways and the sensor that they have. So it's out of the box, and it is just plug and play to start. So you will be shortening your time by connecting the device directly to Cumulocity, where you don't need to the headache of the integration or using the protocol, where it's already certified in Cumulocity devices catalog that you can use it immediately and start receiving the data in Cumulocity. Saying that, because Cumulocity is an agnostic device platform where you can connect any device, regardless is the protocol or the connectivity that is being using. There is some protocols that are already by default, like MQTT, Modbus, HTTPS. So all those famous protocols that has been already integrated out of the box, where you can just connect the device and start monitoring. Or if there is any specific protocol that has been brought new to the market, we can build something, we call it an agent, which will be the bridge to translate the data from the device to Cumulocity to start monitoring the data coming in from there. So the second part, when we talk about low-code, no-code platform, that means you have the whole infrastructure of your device management, and you are not needed to be doing any coding in order to develop your use case. So the only thing that you need is the data is already arrived to Cumulocity. After the data is in Cumulocity, which happened during the integration part of the device. The second part, it will be very simple, very easy. Anyone, even has no development or programming backend, can build the use cases using the data that's coming from the device, because there is no coding needed. So the time of sitting, coding the device, the platform or the application, then testing, then go again and develop again, and then fix bugs, that has been already behind. So now what we are doing is you just need a designer to come and create this data in the way that you want to be shown in the platform. So you can use the same use case, the same data in different style, in different mode, depend on the need of that use cases that you want. So this is one other part that it will help you to speed up your go-to-market, so you don't need to build the whole platform. So in order to develop an application, usually it takes you like months or almost a year to finish like one small application. With Cumulocity, you will be up and running in matter of days. That when you have the data already, you just need matter of days that your use cases and you are up and running to use it. So this is also one of the big advantage that Cumulocity have it. When we talk about oil and gas, we always have a challenge in the location, which Nasri mentioned in the beginning, where like you are in the remote areas, you are working in hazard areas, or you are more focused on areas where there is a specific people or specific asset can operate in that areas. And the built-in geofencing capability, it has Cumulocity, that it allow you to work on that geofences and disallow people based on their category or based on their responsibility to be in such areas or not. For example, that use cases where like some confined spaces, not everyone is allowed to be in that confined spaces, and by geofencing it built in Cumulocity, you will be able to receive the data when there is someone who's not authorized to be in that location, and then it will start using the AP-Way device from Actility. It will start alerting him on spot. So it is not only about alerting the operation room or the safety team that someone is accessing an hazard location. It's also alerting the worker themselves before they get in, so they understand that they are now crossing the border to a dangerous area, that they have to back up and not continue to that location. The third part is where you come to integrate with the third-party applications such as SCADA, SAP, ERP, or you name it. And this is also helping to get the data which is coming from the existing enterprise that you have, like SAP or SCADA or the ERP data, which is the OT data that you have in your operation, and integrate it with the live data that's coming from the sensor through Cumulocity, and then it will give you the real picture of what is really happening there. So you will have, for example, your work package platform that you are preparing your work back in the oil and gas field that to do some task or some work, and that is already planned. So it is only an OT data that is already edited and added to the system manually. And then you will have the real data, what happened actually during that work back. So you assume a work package that it will take you 100 working hours, needed 10 workers and 5 different assets, but the actual data, it will show you if you have planned your work package in the right way, or that you need to enhance that planning for your hand, because it will give you exactly how many man hours has been taken, how many assets has been involved, and then you just do this comparison between these two kind of data to give you exact, are you planning in the right way, are you late, or are you in advance to take an action on that. For that, we have developed like a very advanced solution, which is focusing more in the worker monitoring, site monitoring, and as well as the assets monitoring using LoRa network across a big site in oil and gas field, where the first part, it was about monitoring the status of the worker. So it is as far as we are getting the location from Actility, we are able to get many features out of this location part. So it's not only about I see the location of the worker. It is good, but it's not enough, because in that location I can see the geofence, I know that he's allowed to be in this location or not allowed to be in this location. So you can see like there is different colors. So you have like the red color, gray color, green color on the map, and each color is mean a status of the worker. Either he is in the right location or not, or he is late to arrive to his location or not. And this can help you not only for location, as I say, it will be all having helping you to work more on punctualities, how many people that we have, how is the distance that they are moving around. So all this, it's coming only from feature, which is, we call it location part. By that, as I said about the geofence, so you can create hundreds or unlimited of geofences in your area, and you can monitor the people or the asset moving around this geofence based on the authority to be on that location, and getting a live alert for the system as well as for the asset or for the worker that they are carrying a personal device that we are collecting the data from them. Using all that data that we are getting, we are now able to go and enhance our site punctuality to understand how many people has been attend to this site, how many people has been late, if there is any absence people in the site. And this is a big challenge for oil and gas, specifically when they have the outsource contractors, because you don't know exactly. In the end of the month, you will receive a bill saying we served you with 500 workers this month, but do you really have 500 workers were working there? Are they really coming on time? Are they really need to work overtime on that time? So you will have all the attendance KPIs to understand what you are paying for and how many people there in the site. In the same time, also, this we're talking about the efficiency, but we are also very important from the safety perspective. Is the worker in the right location? There is a lot of accident happen where is a lone worker working somewhere. Something happened to him. He get fall down from a height work location, or maybe he just not conscious because of the heat stroke, or any other reason can happen to the worker, where if there is no location monitoring for his movement, you will be able to forget this worker for days and no one can notice him, specifically when there is a specific area that no one can notice there is someone in there. The next slide is about all the alert and notification that you are receiving from your workers. You will see all this information live in your screens, in your dashboards, and you will be able to take action upon it. So you will be able to either inform the worker what they have to do. So you can send him either a message, you can send him either a ping to his device, or even though it can be going to his supervisor, which he's using the application, and get an action immediately of what it should be done. Either he is late on his task to be delivered, either he is in a dangerous situation that he need to be alerted to be moved out from that location. The next one we will be talking about is about the efficiency and productivity for the workers. So as I said, that's not only about monitoring their location. We are using that data to see the productivity of the workers. So when we have assign a specific task for a specific worker or a specific asset that has been done, so we are knowing that this is the location where it has to be done. This is the time that has to be finished with. And then the system, using the data coming from the devices and activity to Cumulocity, we will start analyze this productivity on the site to understand how many hours that worker has been working, how many potential productivity that we are losing because, for example, the worker is moving from A to B and it takes him more time expected than what we have planned in our work planning. So we have an example here that we found out that the worker need to go to collect his tools from the warehouse, and that takes him a minimum of 15 minutes walking because it's a huge yard. And when we make the calculation that the worker is wasting almost from 45 to 60 minutes on a daily basis just to go twice to collect some tools and coming back, and this is around 20% of his productivity time. So by making the plan and finding this data out, the operation decide to make a smaller warehouse close to that area where it save around 17 to 18% from the time of the worker that he's just wasting in order just to go and collect something. So small things no one noticed, but when the data is coming, we will be able to figure out what was exactly the issue and how we can save it. Similar the same data that we are talking about it of when it comes to worker, it exactly can apply for an asset or a vehicle on the site to understand exactly the movement, exactly the utilization. We have a lot of small machineries like welding machines, for example, on the site, thousands of these welding machines, but we don't know where they are. We have some devices or some machines that is being utilized for thousands of hours, and some they were being utilized only for a few hours because no one have the visibility where are these machines. So using that technology to understand how many hours has been used and where is the location, do we need really to buy new ones if the operation or the site team has asking for, or do we need to utilize what actually we have on the system? So this is in general of what we have work on for a demonstration part. I would be happy to receive your question on that, and just to save the time, I would move the stage to Hussein from Aramco as well. Thank you.
Thank you, Well. So let's now welcome Hussein Al Rashid for the customer perspective.
Okay, so before I start, I just want to introduce myself. I'm Hussein Al Rashid from Saudi Aramco. I've been working on digital transformation since 2017 in Aramco. Before that, I've been working on SCADA systems and other operational use cases we have in Aramco. And I was the SME for a smart city project that we have conducted in Aramco. And just to share with everyone something maybe not everyone knows, that in Aramco we have everything, not oil and gas. We have only our own fleet of aviation. We have our own communities and residential areas, similar to small cities. We have our fleet of buses, cars, and everything. So we have a bit of everything, to be honest, not only oil and gas. And so because of that, we have many use cases that require IoT. And I don't know, the slide, okay. So we have many use cases that require IoT technology. And because of this, we had this design or infrastructure that we have built to address multiple IoT use cases. If we look at the slide here, I don't know if it's readable by you or not, but I'll try to explain what you were sharing here. So the design we have developed is that we have separate layers of data from different sources. Starting from the bottom, you have the sensors and embedded devices, whether it's for operations or smart cities or facilities or transportation, what have you. We have wearables, we have drones, we have cameras, we have multiple data entry points. Some of these require LoRa, or it's more efficient to use LoRa than the other technologies. So in that case, if you use LoRa, obviously you need LoRa gateways to connect to the devices. We have done that for multiple use cases related to safety. One of the projects we actually have commercialized called Raqib, where we track the employees and the workers for unsafe behavior to prevent incidents from escalating. And we had deployed gateways there and in our cities to track the equipment and the wearable devices. Now, once you install the gateways, they have to have software on the cloud to read the data coming from the gateways, process it, understand it, and then push that data to the IT platform. And then the IT platform should process the information come from the sensors. And as the guys explained, we have used Cumulocity, where it makes it very easy for us to allow our proponents to build the use cases. They don't need to come to us every time. And we're using a data hub to push the data from the Cumulocity to our data lake. And then we are enabling other teams in the company to digitize their processes using different technologies such as Gen AI, machine learning, digital twin, autonomous operations. And so the challenge we had was that now once you have the devices going, this is the challenge that if you can see here, that once the data goes through the gateways, it goes to the LoRa server, and then typically you'll have to build this custom integrator between the LoRa software and the IT platform. By doing this, that means you have an extra layer to manage and worry about because it's custom built. And then every time you add a new device, like if you buy a sensor that tracks the one we just did recently, track the food safety, temperature of the fridges and so, you would need to go to LoRa server, configure it there, and then LoRa server will push the data to the IT platform, and then you have to go to the IT platform and build a microservice to understand the data coming from the sensor, which means requires higher cost to develop. So just instead of having the scope just to develop the software, you have to worry about configuring the devices. It takes longer time to convert the devices, understand the data coming from there. There's more breaking points, as you can see, more levels, and higher potential of human error. So if you translate the data coming incorrectly, you will get wrong information, which will mess up the whole AI model that you build. And there's also a know-how challenge. So that's something you do every day. It's not something everyone's doing. So it's really difficult to find any code there to help you do it. So what we did, with the help of Actility and the Cumulosity team, Actility is already configured or integrated has out-of-the-box integration with Cumulosity. So when you want to add a LoRa device, you just need to go to when you go to Cumulosity, you just select an add device, LoRa Actility, and then you just configure without building any code the different parameters that you're reading from the sensor, and then you'll translate it automatically. You don't need a developer to do this. By doing this, you're reducing cost, reducing time for development. So your return investment will be faster and less errors, because then you can just focus on that, not focus on the code, worry about the code, just focus on translating the data based on the data sheet you receive from the vendor. And obviously, it's easy to fix the human errors. Anyone can go and see why. Well, the temperature value doesn't make any sense. So he goes, oh, it was just selected incorrectly. And the screen, to be honest, that's developed today is very intuitive, easy to work on. You don't need to do a lot, really. And thus, by having this, it enables future automations, meaning that the opponent's not reluctant anymore to go and bring new devices. It's easier. They have more confidence of buying more devices or LoRa devices on the market, unlike before. So this is what I wanted to explain to you. Based on our experience. I'd like to thank Actility and Cumulosity for this good product and good integration between the both. So back to you, Janani.
Thank you, Hussein, for these fantastic insights. We will now start reading the questions. Please feel free to add more questions. Okay. So regarding the webinar pre-recording, so I confirm we will be sending an email after the webinar with a direct link to watch the webinar replay and access the slides as well. We have another question from Zoltan To. Would you please mention which kind of technology are you using in case of the mentioned examples, or do you use LoRaWAN in all the cases of mentioned examples? I think this one is for you, Nicolas.
Yeah, okay, I can handle it. No, of course, you have to use the proper technology regarding the use case, and most of the time you may have a mix. So LoRaWAN is really designed for battery-based, low latency, and small messages, and like the trackers, it's only positioning and some alert, the few bytes. But of course, if you need to complete with video cameras and more advanced solutions, you may of course rely on additional technology. And of course, talking on the behalf of Cumulosity, they are completely agnostic to the connectivity, and you can of course coordinating multiple technologies to be able to serve the different use cases that require low bandwidth and high bandwidth.
Thank you, Nicolas.
Yeah.
We have another mention from Omar Case. NTN cellular satellite is one way to work in remote locations.
Yes, it does. There are very huge initiatives in LEO satellites those days, more dedicated for low-cost type of connectivity. a question of cost, and of course, satellite is very important in oil and gas because when you are in isolated offshore systems, you rely on this type of connectivity. Now there are all these many initiatives of LEO satellites capability to be able to interconnect directly sensors to the satellites, but there are most of them are now using a kind of direct, or let's say a small differences flavor for LoRaWAN because they have some beaconing specifications that they need to manage, but there are more and more LoRaWAN activities providing a bridge, a roaming hub able to interconnect satellite LEO players with ground connectivity and can be managed by a centralized platform connected to a single API to the Cumulocity platform. So we can be agnostic to satellite or ground connectivity, terrestrial connectivity. And so, yeah, but LEO satellite is not only can be used for specific use case because the number of satellites is limited and you can only communicate when the satellite is on the top of you. And most of these LEO players, there are only, let's say, dozens of satellites. So it means 12 messages per day. If of course, more you get over the time, you get more and more satellite, then we will increase the number of messages that you can send over the day. So it's again using to adapt it to the use case. For worker safety, you need to, when you press the alarms and you need to be rescued, you cannot rely on waiting that the satellite is on the top of you. That's why you having another strategy by creating a private LoRa bubble. This private LoRa bubble can be then connected as a backhaul to a LEO satellite by optimizing the messaging, or a VSAT type of more bandwidth. This is what we do in many mining in Australia. We create a LoRa bubble connected to a central point gateway that himself connected to a satellite backhaul. Quite straightforward right now. Next question, Janani.
Thank you, Nicolas. In ATEX-rated zones where deterministic behavior is critical and cloud round trips are infeasible, how does Cumulocity orchestrate stateful distributed agents logic across various edge nodes to ensure zero latency decisions, especially when conflicting rules, degraded connectivity, and real-time sensor fusion, like GAS, BLE, UWB, must be resolved locally without centralized coordination? I think this question is for Cumulocity team. Nasri, could you answer, or well?
Will take it. Thank you for the question. So the mainly when it comes to latency, we are having the edge architecture where it can run a lightweight micro agent directly on the site, which can be an ATEX certified edge node. So we don't need to have this cloud round trips. So we can use it directly on the site, as well as we have a real time rule engines, which is Abama. It's already built in Cumulocity, where it will handle all these decisions. So even though if there is any conflicting inputs from different links. That is one part. Also, we can merge, like for example, the UWP, what is mentioned on the question, to be filtered and to be a confidence for the logic that we are having it there.
And to complete the answer, I answer it in writing. For more specific hazardous zone, the tracker, the smart batch tracker, has his internal logic related to the identifying the BLE beacons and can send alarms if you lose completely the connectivity. You can see my answer is in writing. So to avoid any risk.
Okay, thank you, Well and Nicolas. We have another question from Kenfin Ltd. For huge oil and gas use case like Saudi Aramco, approximately how many trackers and gateways were piloted before full deployment? Answer can be given as a percentage. I think this is for Hussein.
Well, I can give you the number. It's okay. We have deployed it in the more than 14 project management sites, and each one of the sites had more than 2,000 workers. And we also used it for our smart city, where we have over 18,000 sensors. where we use LoRa technology. Does that answer the question?
Certainly.
I think yes. Thank you, Hussein. Okay, so it seems we have covered all questions.
I just shared, because I mentioned it earlier during my presentations, the link to this marketplace to serve all the device, to looking for the devices. So you should see I have just put in the chat the link. So
okay.
Yeah, if you want to discover all the very wide ecosystems of devices that serve so many use cases, you can take a look over the marketplace where you can see the link on the chat.
Thank you, Nicolas. So I think we have covered all the questions now. But if you still would like to reach out to our experts, please feel free to contact them by email. You can find the emails in the slide that is displayed right now. So thank you, Nasri, Nicolas, Wael, Hussein, for this webinar. And as I mentioned, we will be sending an email with a link to watch the replay and also the slides. And we can also share again the marketplace link. And also Cumulocity team has prepared a solution brief that will be also sent to you. Thank you very much to all.
Thank you all.
Thank you very much.
Thank you all.
Bye.
Bye-bye.